Ever wondered what makes powerful AI models like Gemini tick? What's the secret sauce behind their impressive abilities? You know, things like generating human-like text, translating languages in real time, and even writing different kinds of creative content. Today, we're diving deep into the heart of Gemini, its default code. Now, before we get too technical, let's clarify something. Gemini doesn't have a single, monolithic default code in the traditional sense. It's not like you can just open a file and see the entire AI written out. Gemini is a complex system built upon a foundation of massive datasets. Think of it as the raw ingredients. Gemini is trained on a colossal amount of text and code, drawing patterns and relationships from this vast ocean of information. Advanced algorithms, these are the recipes, the sophisticated mathematical formulas that allow Gemini to learn, process information, and generate outputs. Neural networks, these are the kitchens, intricate networks of interconnected nodes that mimic the human brain, enabling the model to learn and make connections. So, when we talk about the default code of Gemini, we're really referring to the underlying architecture, the algorithms, and the parameters that define its behavior. These elements are intricately intertwined, forming a complex and dynamic system. Here's a breakdown of key aspects. Transformer architecture. Many of the most powerful AI models today, including Gemini, are built upon the transformer architecture. This revolutionary approach allows the model to process information sequentially, understanding the context and relationships between different parts of the input. Self-attention mechanisms, a core component of the transformer architecture. Self-attention enables the model to weigh the importance of different parts of the input when processing information. This allows it to focus on the most relevant aspects and generate more coherent and meaningful outputs. Pre-training. Before being fine-tuned for specific tasks, Gemini undergoes a rigorous pre-training phase. During this stage, the model learns general patterns and representations from massive datasets of text and code. This pre-training provides a strong foundation for subsequent fine-tuning and allows the model to adapt quickly to new tasks. Fine-tuning. After pre-training, Gemini is fine-tuned for specific applications. This involves training the model on a smaller, more specialized dataset relevant to the desired task, such as language translation, question answering, or code generation. This process refines the model's parameters and improves its performance on the target task. Now, let's talk about the implications of this default code. Versatility. The inherent flexibility of the transformer architecture and the power of pre-training allow Gemini to be adapted to a wide range of tasks. This versatility makes it a valuable tool for researchers, developers, and businesses across various domains. Continuous evolution. The field of AI is constantly evolving, with new research and advancements emerging regularly. The default code of Gemini is not static, it is constantly being refined and improved through ongoing research and development. Ethical considerations. As with any powerful technology, the development and deployment of AI models like Gemini raise important ethical considerations. Issues such as bias, fairness, transparency, and accountability must be carefully addressed to ensure that these technologies are used responsibly and for the benefit of society. Understanding the fundamental principles behind the default code of Gemini is crucial for anyone interested in the future of AI. It allows us to appreciate the incredible potential of these technologies while also recognizing the importance of responsible development and deployment. With that said, thanks for watching, and until next time.